Today, basically, I will be like sharing how someone who is still working in Web2, Web3 as a front end dev, as a React dev. That's basically what I did 6 months ago. Uh, and yeah, just wanted to share how, because I've seen a lot of people who are curious about it. So yeah, just sharing what I've learned so far. Um, by the way, I really don't like using the term Web 2 because I don't want to make it sound like Web 3 is in any way superior than Web 2. But yeah, I'm just using it here for convenience so that it's easier for us to differentiate between the two uh, sectors of our industry. So first of all, just a little bit about me. Currently, I'm working as a front-end engineer for Missouri and Moonshot Collective. I'm a member of Developer DAO. I build lots of open source software there. Basically, all of my work is open source, even Missouri and Moonshot. Um, and yeah, I love building UIs, and I moved to Web3 6 months ago, and now I work in Web3 full time. Uh, so yeah, and this talk is basically like just another version of this post I wrote uh, with the same title. So if anyone wants to uh, read the entire article, yeah, I'll send this link to Kiran, and he can send it in the chat. Um, okay, so before we move on, if you're wondering what is Web3, Web3 is basically all about blockchains and decentralization. Um, so basically, what that means is instead of having a simple server, just a centralized server, you'll have uh, everyone running like this global machine uh, of data which is accessible by everyone and anyone. uh, so if you don't have a lot of knowledge about Web3, like if you don't know what a smart contract is, what a blockchain is, how does a blockchain work, I highly suggest that you like just read up on it a bit, even if you are like not really looking into like moving it there right now. uh, just like understand what a blockchain is, how a smart contract works, and yeah, that will just make understanding this a bit easier. So if you are a front end dev uh, in Web 2, like I really hate saying that word, but in Web 2, uh, you already have like 95% of the skills you need to just move to Web 3 and work for a Web 3 company as a front end engineer. Now, why do I say that? You are just like manipulating the DOM. That's what you are doing with React in Web 2. That's exactly what you will be doing in Web 3, in Web 4, anywhere you go. That's at the end of the day, you are going to be working with websites and mobile apps. It's the technology underneath the abstractions is just going to stay the same. As a front end engineer, you will still be working with React, with Next.js, with TypeScript, all of these things that you are already familiar with. Those things are not going to change. They will stay the same. So if you're thinking that moving to Web3 with all this hype around, you have to know like 1,000 things. You don't. At least to begin, you don't have to know a lot of things. All you need to know is if you want to move as a front end engineer, all you need to know is React or any other front end framework like Vue.js or anything else. If you know how to build UIs with React, you can basically do build UIs for Web3 too. The only thing that changes is the data that you are interacting with, the data sources that you are reading from, and the storage of data, and how all of that stuff happens. And that's what we'll be looking into next. But the most important takeaway from this is that You really don't need to know a lot about how a blockchain works, like behind the scenes. You just need to know like uh, just the important stuff, like just the very basics of how a blockchain works, what a smart contract is, how is it different from a traditional server, how is it different from a traditional architecture, and yeah, you are good to go. Trust me, just don't don't listen to gatekeepers. Just get started if you want to. Just explore this space. Now, what's different between Web3 and Web2? And the reason behind all of this hype is how Web3 handles user authentication, your identity, and storage of data and mutation of data. Uh, so in a traditional app, you will be used to using passwords, emails, or OAuth for authentication. You sign in with Google, you sign in with GitHub, or you have like a password system of your own. In Web3 apps, none of that none of that exists. You only have wallet connections. Your wallet is basically your account, which is like your single identity across all Web3 apps. That's the reason behind why people say that Web3 is a really this big thing, because your wallet is your uh, source of identity that you can take across all apps, and it's owned by you. It's not owned by Google, it's not owned by Facebook, it's owned by you. So that's the first big difference that you'll see. You will not come across a lot of passwords or OAuth connections. You will straight up ask people to connect their wallets, and that's basically how you handle authentication. Uh, and to really verify that the person who connected their wallet is actually that person, you'll also like ask for their signature. So what they will be doing is that they will sign some message using their private key and all that stuff. I don't really want to get into the details, but yeah, you should read up on things like private key, public key, cryptography. Yeah, just the very basic stuff. uh, yeah, but the most important thing is that instead of passwords, you'll have wallet connections. Let me quickly show you what a wallet actually looks like. So if you can see my screen here, this is basically where I work. So in a traditional app, what you'll have here is a login button, which will like show you sign in with GitHub or sign in with Gmail or enter your password. Instead, in Web3, all I have to do is select my wallet and I'm in. This is th- that's all it takes. It doesn't need any passwords. It doesn't need anything. All it needs is a direct connection to my wallet. Cool. Now the next thing is the data sources. So in traditional apps, you are used to communicating with APIs. Like it can be a REST API, it can be a GraphQL API, but it's a server that is running somewhere, hosted by someone, which is serving you data, which is giving you access to uh, modify some data with through post requests, to get through guest requests, stuff like that. But in Web3, you'll basically uh, have to interact with the blockchain directly whenever you are like interacting with a smart contract. So that's basically the difference. The crucial difference here is that instead of like connecting with this server that is hosted by some one person somewhere, you will be interacting with the entire blockchain network, which is run by thousands, hundreds of thousands of people around the world. But you'll yeah, that's basically the difference. What you're doing as a front end engineer still doesn't really change. You are still reading data, displaying it, and when the user clicks on something, you trigger some action, you reach out to someone saying, hey, you need to change this. They change that, and you tell the user that something has changed. The same stuff is still happening. It's just that the data source has completely changed. And not only the data source has changed, the behavior has totally changed too. With centralized API servers, you usually get like a really quick response because it's just like one person running it, right? It's uh, you don't need to worry about everyone on the network agreeing to a change in data. This won't make sense to you if you aren't familiar with blockchain yet, but just bear with me for now. uh, while on a blockchain, lot of people need to know about any changes in data, and that takes a lot of time. So that there's like a big difference in how these two data sources behave. But as a front end engineer, not really a lot will change. You'll still uh, fetch some data on the server, pass it down to your page, display it when someone clicks on a button, and send a mutation to somewhere. It's still the same. You and that's why I said 95% of the stuff is still the same, and Web3 is built on top of Web2. All of this, all of these Web3 apps still rely on React, Next.js, uh, Node.js, JavaScript, all of that. Okay, that's data mutations. Okay, let's dive a bit deeper into data mutations, because they are like I was just saying, they are like extremely different. So in a traditional API, like I just said, it usually takes like milliseconds, like 100 milliseconds, 200 milliseconds. In Web3, when you want to change the data of a smart contract, the whole process is as extremely different. For each transaction, or for each Web3 post request, if you will, there is a cost, and that cost is real money and a lot of time. Now, the reason behind this cost is that a lot of nodes on the blockchain network have to agree and add this transaction to the blockchain. So you have to pay some fee to those nodes, to those people, so that they for their work, right? And this takes time. They have to do some computations, and there's a lot of work involved. And the minimum transaction time on the Ethereum mainnet is like 30 seconds. I haven't seen a faster transaction than that, and it can take up to forever. Now, this usually never happens in a traditional app, because either your API will just send back a response instantly, or it will shout at you that, hey, this is a bad request, or you are not allowed, or something like that. The blockchain doesn't really tell you anything. It just, you send a transaction to the blockchain. You don't even send it. The term that people use is you broadcast a transaction, because you aren't like sending it to one person. You are telling the entire blockchain network that I want this transaction to be added to the blockchain. Now, the time that this transaction takes is really dependent on how much fees your user is willing to pay. Those fees are, you can't control those fees, because your user will open their wallet and select how much fee they want to pay. So as an engineer, as a front end engineer, you won't know how much time this transaction will take. So you have to be prepared for that. This is not something you will be used to doing, and you'll have to maybe persist some state. So if someone refreshes their page, you still tell them that, hey, your transaction is still in progress. So things can get a little tricky here because it is extremely different behavior. Right. The last thing about, well, not the last thing. There are a lot of things that you need to worry about, but one of the most important things is that when you make a change uh, to the blockchain, when you send a transaction, it is immutable in nature. You can't reverse a transaction. There is no delete, if you will, in blockchain. So when you are interacting with a smart contract, when you are calling a function on a smart contract, you have to be extra careful that you are like sending the data in the correct format, that you are interacting with the correct smart contract. Because if you mess any of those things up, it can cost your user real money. And yeah, you can't just reverse it, it's irreversible. uh, like some contracts support reversing things, but that would require another transaction, and another transaction means more money being spent by your user. And that's if you are lucky. Some contracts don't support those things at all. So be extra careful with interacting with smart contracts. Very important. So now let's look at some like direct comparisons on through some code, like some common scenarios. So in traditional apps, you will basically usually be making a request to some server for authentication. You'll send some payload, and you'll usually get use cookies to make sure verify that this user uh, is is like this user is legit. uh, while in Web3, like I just showed you a few moments back, you will be using their wallet, you will be asking them to connect their wallet, and that's how you handle authentication. There's no servers, there's no single source of truth. Well, there is, and that's the wallet, but there's no single source of truth in terms of a server. Now, while we're still at this, you'll also, like, you might have figured out that a lot of this stuff has to happen on the client side. So if your app is like fully Web3, you're only interacting with smart contracts, um, you won't be utilizing servers that much. Like, you may use server side to fetch some data, but anything other than that, like authentication, anything has to happen on the client side. And that's like one of the like important things about Web3 is that you don't trust, you verify. So the users control how they uh, interact with stuff. So they control their wallet, and their wallet is obviously on the client side, and none of that goes through to the server. Okay. uh, Anyways, let's compare how you read data in Web 2 and Web 3. So Web 2, you're like obviously familiar with, like just making a simple get request, getting some data, displaying it. In Web 3, like you're still like making a request, getting some data, and displaying it. But how you get that data is quite a bit different. So you have to like create a contract object. You need to pass in that contract's address. There's this thing called ABI, which is like the type definition of the contract, if you will. If you read up on that, you'll figure out what it is. But yeah, for now that's enough. uh, and the provider is, yeah, I think you'll have to read up on that, but the provider is basically something you get from the user's wallet collection. So you need to have like a wallet connection in order to do this. um, or you need to have like your own blockchain node. But yeah, I don't want to get into too much detail. Uh, so yeah, once you have a contract object with you, you'll just like call a function. In this example, it's called balance off. It's literally a function. You pass in like some some parameters. In our case, we are just passing an address. So I want to query someone's balance on some contract. This is basically what I would do. And once I get that back, uh, I can use that data to display it however I want. Now, one more catch here is that uh, smart contracts don't really represent numbers as we know them. They use this thing called big numbers, which is which is like a format used to display numbers which are really large, so large that they go beyond the maximum limit that JavaScript supports. So that's why you actually need to apply that toString method in order to convert them in a readable format. That's just the way it is. You can't really do anything about it. But yeah, that's a gotcha. If you instead do two number, your code will break. So always do toString. Okay, there's a typo in my presentations, but this is about writing data. Uh, so in a traditional Web2 app, you would be sending some data using a post request to some API. You all are familiar with that. In Web3, again, you would be creating a contract object, passing in an address, an API. But in this case, you'll notice that we are not passing in a provider, we are passing in a signer. So a signer is different from a provider in the sense that a signer has access to the user's like private key, but not directly. You can't really access that user's private key, but you can use this object to request transactions in behalf of your user. They still have to approve it, but just know for now that a signer has access to the private key. You can't access it, no one can access it through the code. It's like internally encrypted. That's like a really bad explanation, because if you want to explain it, it can take a long time. But yeah, that's just for now. uh, and if you want to like mutate some data to a contract, again you would be just calling a function and passing in an argument. So in this case, we have a greeting contract, so we just want to set the greeting and we are passing in the string. This once that line of code is executed, uh, the transaction will be broadcasted to the blockchain. uh, well, before that, the user will see a pop-up and they'll have to confirm the transaction, and that's where they choose how much gas or how much fees they are willing to pay. And after that, the transaction will be broadcasted to the blockchain. Now, you can't just do you can't just use res like you would in the Web2 example. In the Web2 example, you would just use res.data and you have the data. In this case, you actually have to wait for the transaction to be mined. um, there's a different method to wait for it, because the promise on the second line actually resolves when the user confirms the transaction, and it's out to the blockchain. That's when that promise is resolved. But the one below that, that one gets resolved when the transaction is actually confirmed and added to the blockchain. So you definitely need to be aware of this, because I've seen a lot of new devs coming into Web3 not doing this, and just they just see that code breaking. You have to wait for your transactions to be mined. Otherwise, you can have like all sorts of problems in your code. So yeah, that's just a gotcha for you. Um, so if you wanted like a rough roadmap on how to get started with Web3, if you are curious, if you are just willing to explore, I highly encourage doing so. By the way, that more people just give Web3 a chance and have a look and decide for themselves if they are interested or not. This is basically a rough roadmap that I have for front end developers primarily. So first of all, you should learn about blockchain and Ethereum fundamentals. Uh, this is like biased in the sense that I'm displaying everything for Ethereum, but there are other chains like Solana and stuff like that. But you should learn about blockchains, and you don't need to learn everything in detail. You should just know how a blockchain works in very simple terms, just the very basic stuff, so that you know what you are dealing with. Y- You should learn what a smart contract is. You should learn about wallets and wallet connections in Web3. Again, providers, signer, and different wallet providers. These are extremely important things. You'll be dealing with these things on a daily basis if you are a Web3 developer. So you absolutely need to know about this. Uh, yeah, and the next thing you should do is just create a front end, just a simple Next.js app that lets you connect your wallet and shows the connected wallet's address. Uh, the article that I mentioned at the start of this presentation has a link to all these resources in that post. So please refer to that. There's like a lot of playlists. There's some posts that I put. Uh, so yeah, please have a look at that. The next thing you should do is create a front end that actually interacts with a smart contract on a test net. uh, and you can start by interacting with a simple creator contract that is literally just lets you read a greeting and lets you set a greeting, and you'll have like most of the fundamentals under your belt. A few extras that are useful is knowing how ERC20 and ERC721 tokens work, how the entire flow works, how what are approvals, how does the transfer work, stuff like that. And lastly, but very important nowadays, because this is extremely still new, and more apps are moving towards this, is sign in with Ethereum. So this is the thing that I was talking about, like signing messages and letting the front end know that this is actually me because I just signed the message with my private key. This is it. This is sign in with Ethereum. I also have a resource link for that in the post, so please have a look at that. And once you have all of this under your belt, you are like more than good to go to start working as a Web3 front end engineer. Uh, yeah, there's if you I'm sure you must have noticed that not a lot of things are different. You are still doing the same stuff, but it's just the data sources that you're interacting with. Those basically change. Uh, yeah, that's basically it. I hope this was somewhat useful. Um, and I hope that some of you give a chance to Web3 and the stuff that we are building, and yeah, just give it a go. And if you have any questions, you can reach out to me on Twitter. I'll be more than happy to like walk you through your doubts and stuff like that. uh, yeah, thanks for listening.